This is the summary created from the video. Lecture 22 Demonstration IX. An interface defines the contract for a class implementation, ensuring that certain properties are upheld. It demonstrates how to create an interface, package it, and implement it in a class with methods. Interface methods are implicitly public and abstract, while variables are public, static, and final. A class can implement an interface and override its abstract methods with functionality, showcasing dynamic binding through runtime. Polymorphism with interface objects and references. While an interface itself cannot be instantiated and objects cannot be created directly from it. Declaring interface variables and arrays of interface types is permissible without instantiation. Interface methods must be implemented and cannot be private. This program demonstrates the usage and implementation rules for interfaces. An interface can have fields declared as public, static, and final as well as abstract methods. However, instance variables are not allowed in interfaces, leading to an error if declared without modifiers. A class can implement an interface, gaining access to its members and methods. Importantly, an interface cannot implement another interface or an abstract class, as this is invalid syntax. Interfaces cannot have final or static methods. They can only have public and abstract methods. Implementing classes must use the public access modifier for interface methods, and interface methods without implementation are implicitly abstract. Attempting to declare static interface methods will lead to compile errors in implementing classes. Proper naming conventions for class files are necessary for successful compilation. One interface can extend another, inheriting its members and methods. For example, interface I2 extends I1, inheriting member X and method 1. A class A1 that implements I2 also inherits all members of I1 through this inheritance. A1 declares its own variable and implements all the inherited interface methods. The main program creates an A1 object, calls its methods, and accesses the interface variables, demonstrating single inheritance in Java interfaces and classes. Multiple inheritance is demonstrated with a class implementing both I1 and I2 interfaces. Class can access the methods and static variables from these implemented interfaces. Another example is class A1 implementing I1 and I2, showcasing another way of achieving multiple inheritance. Class B extends A and implements I, inheriting from both the superclass and the interface. Additionally, class B implements the print method from interface I and calls the superclass constructor. Interfaces enable multiple inheritance by allowing a class to extend another class and implement interfaces simultaneously. A class can implement multiple interfaces, inheriting the variables and methods of each one. Interfaces also allow shared global variables across classes and packages, promoting code reuse. An example shows an interface with constants used by classes to return random values, demonstrating how interfaces enable shared resources, flexibility and modularity in code design. An interface defines variables and methods that are shared by its implementations. Different classes can implement the same interface in their own unique ways. In the main program, objects of these implementing classes are created. A single interface reference can then access various implementations, with the output depending on the type of object referenced at runtime, exhibiting dynamic polymorphism. Both abstract classes and interfaces exhibit polymorphism through method overriding. In this example, circle, rectangle, and ellipse extend the abstract class geometry and override its methods. The main class declares an array of geometry objects and dynamically instantiates the subclasses. A loop then calls the area method on these objects, displaying polymorphic behavior at runtime. The key difference is that interfaces allow multiple inheritance, while abstract classes do not. Abstract classes and interfaces are largely similar concepts, both exhibiting polymorphism through method overriding. However, the key difference is that abstract classes can have method implementations, while interfaces cannot have any method implementations. Feel free to practice with provided demo programs and post any remaining doubts or queries. In summary, an interface defines a contract that ensures class property adherence. Interfaces cannot be instantiated directly. but references and arrays can be declared. Implementing classes override abstract interface methods. Interfaces allow multiple inheritance, providing shared constants and resources across classes, while abstract classes can have method implementations but do not support multiple inheritance. Please stay tuned for more summary videos.